Hi. You are here for the commercial pilot training, right?
Yep. Wow, this is a bigger monster.
Haha. Yes, this is your new office. I know you did your multi-engine on the Duke. Well, this is the Chancellor. Not very different than the Duke, but while that feels like a sports car, this feels like a luxury limousine. We'll now go through some of the more important changes between the Duke and the Chancellor. But first, listen to that crackling. That's the engine cowling expanding and contracting while the engines are cooling after a flight. The first change you may have noticed are the bent propeller tips. These act like winglets on a wing, decreasing parasitic drag. At 2700 RPM at rotation, the tips can reach Mach 0.88. That is a very draggy regime. These winglets dial down drag and let more engine power go into thrust creation instead of fighting off drag. Another noticeable thing is the 6 places that passengers can occupy. As I said, the Chancellor is a limousine. While 5 passengers could be taken in the Duke, including the right forward seat, the 414 can take 6 without the forward seat. And there's a somewhat clear separation between the flight deck and the back cabin. Here we come to our first major difference: the engines. The Duke and the Chancellor employ turbochargers to keep the high power output throughout extensive altitude ranges. But while the Duke uses a pressure differential controller for wastegate operations, the 414 uses a sloped controller for the same gate ops. The system used on the Duke is more prone to overboosting the turbo because it looks at pressure differential between fore and aft of the throttle plate. The Chancellor's controller only cares about outside air pressure to regulate the wastegate. It is a more stable system, keeping the engine safe from overboosting the turbo and destroying the pistons inside. Talking about engines, we have to mention the Ram 4 calibration program. The original Continental TSIO 520NB engines were rated for 310 horsepower at the shaft. Engineers thought about increasing power without really changing the engine that much. Thus, they increased the maximum manifold pressure the engine could take from 36 inches to 41. This made the engine provide 325 horsepower to the shaft at 2700 RPM. Because this change made the engine components take on a bigger bang, the temperatures inside the engine increased to dangerous levels, so the same engineers modified the fuel flow intake, giving the engines a very rich mixture on takeoff. Using fuel to cool the engine was genius on their part, don't you think? As you can see, there is no engine monitoring tool for the engines. You only have to look at the analog engine instruments to manage them. Also, for leaning, you have specific performance tables for max power, basically rich of peak, and the EGT indicator for lean of peak. Thus match the tables for ROP and lean to max EGT for LOP. Staying with the engines, the Duke doesn't have a way to use fuel from only one tank if you so desire. It can use cross-feed to get fuel from both so that imbalance is not achieved at engine failure, but there is no way to actually feed the right engine exclusively from the left tank. Well, the Chancellor has that possibility. You can feed the right engine from a cross-feed setup, from the right tank or from the left one if you so desire. As cabin pressurization goes, the 2 aircraft act in the same way, taking pressure from the turbo compressor to maintain cabin pressure. However, while the Duke uses pressure gates to regulate the bleed air, the Chancellor uses sonic venturi to achieve the same goal. While indiscernible in normal ops, the sonic venturi present a more stable way of maintaining a comfortable cabin pressure. Also, the Duke had a smaller maximum pressure differential to manage at high altitudes than the Chancellor. However, the Chancellor can have 6 passengers consuming that precious oxygen while the Duke only has 4. Of course, just as in the case of the Duke, the 414 has a full-feature icing system. It has heaters for anti-icing and pneumatic boots for de-icing. The only mentionable difference is that it only has de-icing for the pilot's windshield via DC current. The airframe de-ice system has a reset position that will reset the cycle if needed. Now, a serious departure from the Duke is the hydraulic system. The 414 is the first aircraft you fly that has a dedicated hydraulic system. The reservoir is housed in the right engine cowling, and its fluid level can be checked during the walk-around. This system powers the landing gear operation and the air conditioning compressor. The landing gear is extended and retracted via hydraulic pressure. The backup to this system is still hydraulic. While the Duke had a manual backup, the Chancellor has a pressurized hydraulic fluid bottle in the nose that can be punctured to operate the gear by using the red handle. Of course, you have to make sure that the bottle has enough pressure during the walk-around. As I mentioned, the AC compressor uses hydraulic pressure and does not need direct engine drive to cool the cabin. This makes it possible to use the AC in idle power on hot tarmacs. Everything for passenger comfort. The heating side of things, however, is using a gasoline heater, just like in the Duke, with the added feature of draining fuel from both tanks and not just the right-wing one as it was implemented in the Duke. However, there are more mixing options in the 414, and the system is more manual than the auto heat found in the Duke. The AC effect can be diminished by turning the cooler knob to the left, while it can be emphasized by taking that knob full right. There are two wing root heat exchanger inlets that the pilot can manipulate to set how much cooling does the turbo air get before entering the cabin. At low altitudes it needs full cooling to stay at breathable levels, but at higher altitudes where air temperature decreases, it will need less and less cooling just to keep a comfortable temperature inside. Last but not least are the GPS units. While in the Duke you have the GNS 530W, in the Chancellor you have the GTN 750. There is no difference in precision, but there is one in operations. GNS comes from Global Navigation System, while GTN comes from Garmin Touch Navigator. On the 414 you can touch where you want to go. This expedites ATC requests and makes flight plan customization easier. Also, you can now track airways.